Hi guys, and welcome to today's video on using Pythagoras' theorem in spheres. It's actually the last lesson in this section for further maths, and it is a fairly funky one. Now don't worry if you are not doing maths over here in Australia. Pythagoras theorem, spheres, really important stuff, and worldwide, because maths is of course a constant. If you haven't already done so, head over to MaffsGuru.com where you can find all these videos organized by chapter and by title with downloadable notes. And if you can also head to YouTube and subscribe, I'd be deeply grateful. It just helps me know that people are watching. I'm never going to be rich, and I'm certainly never going to be famous, but just knowing that people are watching is greatly appreciated. Leave some comments below if you're on YouTube, and let me know what you think of the videos. I'm doing my best here for you to ace these exams. Okay, Pythagoras theorem in spheres. We have met Pythagoras theorem pretty much all the way through this course. And we know that c squared equals a squared plus b squared. It helps us find the length of lines for right angle triangles. Now, whether we're dealing with spheres or hemispheres or whatever else, and we've already had an example of this previously, where we had to find the radius of a small circle as opposed to the radius of a great circle. We just need to make sure that when we have a triangle, we label that c squared is always the length of the longest side. And once we know that, we can find other side lengths or whatever. Now, I'm going to use one example to show how we apply this. Now, there is a hemisphere, no different from a sphere. As I say, previous example, previous video, there are examples where we use the earth and radiuses to sort of work all this stuff out. But the pond in the shape of a hemisphere of radius 5 meters. Now, they haven't put anything on there, but I'm going to write 5, and a water depth of 1 meter. So we know the depth from here to here is 1 meter. Find the length of the water line. Now, what on earth is the length of a water line? That basically is this length all the way around here. So the water line is the line of water, and it wants to know the length. That's another way of saying find the circumference. Now, how do I find the circumference? Well, for that first dot point, to find the circumference, I need to do 2 times pi times the radius. So I need to know the radius, which in this situation is the length of AM. How am I going to find the length of AM? Right, well, I need to know, I've got a right angle triangle there. So I have O and I have M. I know that's 5A. I need to find this length here, which means somewhere they have to have given me this length here. And they have, as a trick. If you remember, O to the very bottom is actually 5 meters. And they told me the length of the water, or the depth of the water, was 1 meter, which tells me that this, in fact, is now 4 meters. Oh, awesome! So knowing that, I now can use that 5 squared is equal to 4 squared plus AM squared. Now, some of you are already screaming at me, but this is a 3, 4, 5 triangle. I know, just chill. That's going to be 25 is equal to 16 plus AM squared. So AM squared is going to be 25 minus 16. AM squared is 9, and so AM is equal to 3, because I'm going to do the square root of 9. So I now know AM is 3, which means I can now find the circumference, or the length of the waterline. So C now becomes equal to 2 times pi times the radius of 3. Firing up my calculator, 2 times, bring my keyboard back, pi times 3 gives me the fabulous value of, what does it want? It doesn't actually say what to give it to, so we'll say 18.85 meters. Awesome. Find the area of the surface of the water. Well, okay, once we know that the area is equal to pi r squared, in which case that's pi times, again, the radius is 3 squared, which is going to be pi multiplied by 9, which gives me 28.27 meters squared. And the shortest distance along the surface of the bowl between L and M. Okay, the next part of the question, the language is really confusing, trust me. I'm just going to, I don't know what I'm going to do. Right, let's scroll over a moment and use my diagram. So basically what it's trying to say is it wants you to find the shortest distance along the surface of the bowl, or the top of the bowl, to go between L and M. And what that's really saying is if I have this here as my bowl, we know that here is L, and here is M, and it's saying, well, if I was to now go vertically up between those points, what would the distance be between here and here? Random question, but it says basically to use, what does it say? It says to use the great circle through L and M. So the great circle is that diameter of the bowl, or that sort of this whole section here I'm trying to highlight. So what do we know? Well, I've got this here and there and there. So drawing this out again, I have this point L and that point M there. I know that this length here is 5 because that's a radius. But do I know anything else? Yes, we know the distance between L and M is actually given by, well, we know the distance between L and M because they say in the question is actually, it's 6 meters long. Why is it 6 meters? Because this here is 3 and that meter there is 3. So we know the distance between those two because we found it out. Okay, so knowing this, what do I need to find? Well, I need to find this angle here to help me find this arc length there. Okie dokie. Right, so we've got a way forward. How am I going to do that? I'm going to split this into a right angle triangle because that means I can find this angle here using trigonometry. So using some trigonometry, I have this is 5, this is 3, let's find theta. So that's opposite over hypotenuse, so we know that sine of the angle is equal to 3 on 5. So theta becomes equal to sine to the minus 1 on 3 on 5. Okay, sine to the minus 1, if you will, please, of 3 on 5. Close the brackets, press enter, gives me theta is equal to 36.87 degrees, rounded to 2 decimal places, but obviously I'm not going to use that. So we know now that this whole angle there is double that. So if I double this, that's going to give me 73 point whatever. So here we go. I've got my subtended angle now at 73.74 degrees. I know that that's 5, and so I can now use my arc length formula to say that the length then between L and M is given by 73.74, the fraction of the circle multiplied by the length, which is 2 times pi times the radius of 5. So let's do this, please. That's going to go in there. I'm going to divide that by 360. I'm going to multiply 2 by pi and by my radius of 5, which gives me a distance of 6.44, I think it was meters. And there we go, ladies and gentlemen. That concludes this video. Thank you very much for watching. That example is representative of lots of different examples, spheres, hemispheres, all the same, really. I hope you've enjoyed it. Thank you very much for watching. If you can, subscribe on YouTube, head over to MaffsGuru.com and sign up, and send a shout out on TikTok or Instagram or wherever you can. Just let people know that these resources are here to try and help them do well. Otherwise, I'll see you in another video. Take care of yourself and stay safe. Bye-bye.